I want everyone here to have the opportunity to start working with the code themselves. This next example is, I'm still going to be showing you what the code is, but it's going to be an example you can follow along on your own system with the code I'm writing. So we have the ZKVM Rust template. We have a public template that you can, it's a GitHub style template, and you can use it to start your own projects. So I'm going to go to this link shortly, but let me tell you what's going to happen there. So it's just a GitHub link. You can clone the code normally if you want, but you can also use the GitHub template feature, which is going to give you a clean history, and it's not going to point you to the template repository as a remote. So this is useful for standing up your own projects so you don't like try and submit PRs to the template code, which we are definitely not going to accept if it's your own project rather than fixes to the template. So let's go through that. What's happening to make that happen? So here we go. I'll just show you how this works. You can use the use this template. This is probably not large enough for you to see. One moment, let me make this bigger. Hopefully that's more, actually probably even bigger. Hopefully that's enough room for the UI. Let me make this full screen as well. So I'm going to click the use this template button, create a new repository. Again, if you don't actually want to create a repository on GitHub, you can instead follow along by cloning in sort of the traditional manner. And I'm perfectly happy sending this to my own personal GitHub account, but you could put this in a group account if you wanted. ZKHack demo, actually ZKHack 3 demo, because I might be back here again. That would be cool. I'm going to make this public because I'm telling everyone about it, and create repository from template. It's going to think about it, making a new GitHub repository for a project. Should only take a few seconds according to GitHub, and indeed it did. And now this is a standalone repository. History is just one initial commit, and we can clone it in the usual way. Whoops, I don't want to be in this directory. Right. You can clone it in the usual, clone it in the usual way means type git clone. There we go. We can clone it in the usual way.
You might want to size of that.
Oh, I definitely want to make this bigger. Thank you, Brian.
And then just real quick for the two questions that people asked. There's one question about, Jeremy, I guess you could take both of these.
Yeah, certainly. The question was, could you add a bit more detail about to this distinction you've made in CIRCOM, NOR, et cetera, you're compiling a circuit for a given program. But for RISC Zero VM, you're generating a circuit for the VM. It sounds like the circuit doesn't vary per program. Is that accurate? And the answer is yes, it's accurate. The circuit is just implements the risc-v VM, and then we basically pass the program as input to that circuit. So the circuit is, you're never recompiling circuits. And then, yeah, with regard to the roadmap, actually, Redford, do you want to take the roadmap?
Yeah, I can talk. I'll take. So one elaboration on the prior distinction. We do support accelerator circuits, and we're not really getting into that. That's going to be a even later workshop on how to build those, because that part's not open source yet. But in that case, the circuit or like SKU you're running on might differ based on which accelerators are attached to your RISC-V circuit. As far as languages other than C++ and Rust, absolutely. Go is very much on our roadmap, although we would certainly love community support on that. Where you can find our roadmap right now is nowhere. However, we are doing an offsite next week, and one of our key sort of outputs from that is going to be a fairly detailed roadmap, including what kind of things we're hoping to work on, what kind of things we'd like help on, all this stuff. So we're going to really start trying to engage the open source community in the very near future in a much more transparent way.
Awesome.
So just to answer a couple more questions that have popped up. One question is, how many constraints in this monolithic circuit? Is it a single circuit or a collection of smaller circuits with recursion in the back end? So the answer is it is currently a single circuit. We do have recursion support, and we're going to be using that for doing the continuations mechanism I mentioned earlier that allows us to run much larger programs. But right now, it's a single circuit. It is a Stark-based system. We are using about 200 some columns, and there are order 15,000 constraints roughly. So hopefully that helps. And the constraints, the next question, one of the other questions is how are the constraints defined in RISC Zero? And in our circuit is being a Stark, it's roughly error. Although we have an internal compiler that actually generates that error from a higher level language. Currently, that compiler is not open sourced, but we intend to also open source that circuit compiler as well.
Great. Right. So if no more questions, I'm going to get into writing code that you can follow along with, so you can see how to program a code from our template by following along with me. I'll also, I think at the end of me going through this, we'll take a bit of a break, and that will give opportunity for people, if they've been following along but didn't catch what I was typing and hit a bug or something like that, we'll have a chance to fix that or take questions, anything like that. So the plan is sort of at the end of this, we're going to do our break. So as I had mentioned, I'm just going to re-show this before, since it was from before the questions. I went to, I guess this went away. I went to the RISC Zero Rust starter repository. Here is the link. Is this pasted in chat? Because if not, I should definitely paste it in chat. I'm going to paste that in chat. Okay. So went to the RISC Zero starter repository. You could clone this in the traditional sense if you don't want to put up a new repository on GitHub, but it's easiest for creating new projects to do this, create a new repository. Therefore, that way you don't have the history associated with it. So I did that, and then in that repository, I, in the standard way, cloned it with this command, and I'm gonna hide these. I cloned that with this command. Okay, so with those sort of basics out of the way, I will say we can, I'm going to enter the directory I cloned this into, which I cloned into zkhack3 demo. And now, just before I get started, I'm going to run cargo run. It's a blank cargo run with the -r parameter because you want to compile for release, because while it does make the compilation a little longer, it makes the execution substantially faster. And that can add up. And it's going to take a bit to do first-time compilation. And then once it actually runs, it's going to do nothing. The template is a blank template for you to be able to fill out, so this code doesn't actually do anything yet. So while that's compiling, I'm going to start talking about how you use this template, how you fill it out. So there's a README section explaining this, and we're not going to go through all of it because I'm just going to tell you. But a key point is there are to-dos scattered throughout the project. You can search for to-do, and it tells you where you need to make changes to turn this into an actual project. And then the rest of the README sort of says some places you should expect to-dos, tells you things like, hey, be sure to check the gitignore file and make sure it matches what you want it to be, etc. Rewrite this README, that sort of stuff. So let's go look at sort of the core functionality. So when I showed you the factors example earlier, there was guest code. That was the first thing I showed you. And that lives in methods, guest, source, bin in sort of your standard layout and the way the templates lay it out. And here's that guest file. So this is one of the files we'll be editing. And the other file we're editing is going to be the host code. I'm going to close these messages. It's going to be the host side code, which lives in host, source, main for the template. And these are the two we're going to be doing. Oops, sorry, I'm trying to move. Come on. There we go. I'm trying to move the you're sharing your entire screen message, which was in my way. Right. So let's look at the guest code first. That's what we started with factors. That's what you're going to start with here. Oh, and I didn't say what project we're going to do. That was an oversight. So what are we trying to accomplish? Let's write a password checker. Let's say, passwords, you often have your password must contain one uppercase letter, one lowercase letter, one symbol. This is not, I believe NIST actually recommends against this, but it's a very common thing. So let's try doing it. And let's try writing a password checker so that we never actually have to share our password with anyone. We can instead share a receipt. And that receipt says, here's the hash of my password. That's all you need is my hash. And because I ran this in the ZKVM, I have a proof that it meets your password condition. I'm going to have a proof that it includes a special character. That's the condition we're going to check for. And so that's our goal. Right. Okay. Now I can come back to the code and say, let's actually implement this code. Okay. So the very first line in the guest code in the template says, hey, rename this file. The file name should be what you're trying to accomplish. So we're going to rename it from method name. And I'm going to go ahead and rename this to, we're checking the password. So password checker is what I'm going to rename this to. Oh, and I deleted the message a little quickly, but it said you also need to change a constant in the source. So I'm about in the host side. So I'm about to go to the host side. Over here on the host side, it said I needed to change a constant, and the host side has a to-do right at the top telling you the same thing. Change these constants to what you just named your method. So instead of method name ID, I've now named it, and it's now PW check ID. PW checker. I'm going to rename this PW check. PW check ID. So PW check ID and PW check path. And RISC naming conventions say these should be all caps. So even though I wrote this file name in lowercase, our build script is going to convert that to uppercase in creating these constants. So I use all caps here. I'm going to copy these. Since I made these changes, I need to change them elsewhere in the file as well. The ID shows up in 2 places, so I changed that here. And here you could also use Command F to find all the places you need to change. Change this here and here. Okay, first do's are done. Just follow the instructions. Then, I want to point out before I keep going, this is now finished running, and as promised, it did nothing. If you are following along on your own example, and you hit a problem here, you can let us know. I'm a little surprised, but you can let us know. And I can take a break at some point to help with that. We can talk about it sort of during the break. Let me come back to the guest code. So I came back to the guest code. That's pwcheck.rs. It mentions the standard support is experimental. It generally does work, but it is a little experimental. And actually, in the chess example, there's a slight bug in 0.11 that we're going to run into. It will be fine. We have a workaround. But I actually want to use string, so I'm going to remove the no standard. And okay, let's think about what we want to do. We want to receive a password privately, confirm that it contains a standard character, or a special character, and return the hash by committing it into the receipt. So first we need to load the password. So that password is going to be a string. And you do need to explicitly specify the type because there's no type inference across the host guest boundary. And env read gets you the first, if there's more than one input, it gets you the first input being provided by the host. And we need this env, and that is in the RISC Zero ZKVM guest crate. So we add that as well. We are implementing our guest code already. Okay, now we need to check that this contains a special character. So okay, what are we going to do? I'm going to loop over all the characters in the string, check whether or not it is a special character. And if it is going, I'm going to set a flag saying, yep, this is fine. And if not, I won't. And in the end, we're going to see if that flag is set or not. So let's set up a flag. So let is okay equal false. And then for character and PW cars, we're going to check, oh, this needs to be mutable. Let mute is okay equal false. We're going to check if the character is, I think it is ASCII special. I ran through this code earlier. I think it's ASCII special. The compiler will complain if I'm wrong about that. Then is okay equals true. And then once we've checked every character, we're going to see if it's not okay. Well, we don't want to generate a receipt. So to prove that there is a special character, we want to panic if there isn't a special character. So we panic. And then I said we wanted to put the hash in the receipt. So we use env-commit for that, but first we need to compute the hash. And for SHA, we have a built-in accelerator. You could, in principle, compute SHA naively, but the performance would be bad. So we have a built-in accelerator for that. So that's the SHA functionality. And so to compute the receipt, we say let digest equal SHA digest U8 bytes, I think, something like that. It will complain if I'm wrong. Digest U8 bytes of the password, and SHA needs it in U8, so we get it as bytes. This is just the REST function to turn your string into the bytes that encode it. And then we want to put that in the receipt, and env commit is how you put something in the receipt. Okay. And I would sort of like to test this, but if we try and, well, we're going to get an error definitely because we haven't passed anything to the guest. We're not looking at the receipt, but we are running the guest code. So okay, to just run that, see if we get an informative error. Yep, we did. Oh, yep. Informative error said I didn't use the word use up here. Thank you, REST. Let's try that again. This is why we test early, even if we know it's not going to work. Is ASCII special? I thought I knew that name is special ASCII, maybe? If that's not it, we're going to look this up online. Okay, we're going to go look this up. So, oh, nope, let me use wherever Firefox is. Rust character is ASCII special. Rust is ASCII punctuation. Okay, is ASCII punctuation. Thank you, Rust. This is a real developer experience. This is just how it looks to write code live. Okay, let me make this terminal a bit bigger so I can read the error better. It's digest U8 slice, not digest U8 bytes. Sure. Okay, so that is optimistic that we're going to run into problems now with the host not actually providing the data the guest needs to run correctly, given how long it's taking to compile. Okay, so let's go back over to the host side. Yeah, okay, so this compiled successfully, and then it panicked, unexpected end to the deserialization. It tried to deserialize an input that was not provided. So let's go over to the host side and see how to provide input. So on the prover, we're just going to say prover.add input input of, and well, we want to provide some password. So, okay, we need to provide a password first. Sorry, let's set that up. Let password be string from password, and make sure to include a special character. Excellent password choice right there. So we're gonna add an input of this password, and I mentioned this a while ago once. You also need to serialize into U32 words, and we have a helper function for that. That's in fact included in the comment up here. It's this toVec. So add input toVec of the password, unwrap. I think some of these might need to be borrows, but that's okay. We'll work that out in compilation. And we're in to do implement communication with the guest here. That's what we just did. We sent over the information. Whoops, cancel, save. And now we can run. Right. I think this is what's needed. And I think this is what's needed. As I said, I thought there were some borrows missing. Right, and we got a warning about from slice, but this ran, and it ran successfully. We have, in fact, at this point, since we provided the private input, and we've written this code, we have proven that we provided a password that did include special punctuation. And in fact, if I take this exclamation mark out, we will see that since there is down here on line 22, there's a verify step. We'll see that we get a problem. It panicked at an explicit panic, and we get an error message about, well, the code should prove unless you had an error or you overflowed the cycle count. So that's good, right? We really do have a proof. And now the sort of last finishing touch is to see what the hash is to sort of work out what the verification side looks like. So here we have the receipt. We've verified the receipt, but we haven't actually looked in the journal yet. And so we're going to use the from slice deserialization to read into the journal. We say let the SHA digest, which is a SHA digest type, equal from slice of receipt get journal vec. I think both of these need an unwrap. And we're going to print the line that we prove this hash came from a password with special characters. Digest. And this digest is the SHA digest type that works with our custom SHA accelerator. So we need to include that. Use RISC Zero. ZKP, Zero Knowledge Prover, is where the SHA algorithm lives. I think it's core SHA digest. And because we need to use SHA and we need to use the ZKP crate, that's not included by default in the demo. So I add it to the cargo file just in the host directory over here, and it's the same version as the ZKVM. And this will hopefully run. Let's see what bugs it says I have. Oh, okay, right. Hyphen, not underscore. There's a problem in from Slayo. I need to borrow stuff. I think I left my password without a special character in it. So that's why it didn't work. I was trying to prove something false. It doesn't like that. I didn't click save. Try it again. And there you go. If you've been following along, which admittedly I was going a little fast for following along, but maybe hopefully you did. Hopefully you could. If not, I'll help you catch up. We have proven a password with this hash has special characters. This is the password, but the receipt doesn't tell you that. You only know that because you're looking at the host source code. So this is an opportunity. I'm going to take questions. We can about the code or about things in general. You can also stretch your legs, take a bit of a break. Yeah, questions.
So I'm just going to answer some of the questions that came up. One of them was about how easy it would be to add metering, gas metering to the VM, and how would we imagine that working? The answer is that some of that will be sort of worked out when we get to sort of putting this onto more blockchain use cases. But generally, the nice thing is that one instruction cycle is a very straightforward way to meter. The most of the time spent is in actually doing the proving, and the proving is more or less linear with the number of instruction cycles. So in this case, the gas would literally be just number of risc-v instructions run, more or less. And then the other question that was, the journal could, for example, also store multiple digests, and the answer is yes. The journal is just effectively, it's a free-form serialization buffer, and you can serialize whatever you want to the journal. So you could put out multiple digests. You could put out, you could in fact put the entire string. And I think in our chess example, we're going to put like the chessboard into the journal.
And we're gonna, sorry, just to interrupt because I know in an upcoming example, we're gonna have an upcoming example where I show a design pattern for having structured output. If you just write multiple things to the journal, you have to know how many bytes they each take and read out the appropriate bytes in each thing if there's more than one. But you can create an object that, each entry in the object is an output you expect, and that's an easier design pattern to code safely with. And there's going to be an example of that in the JSON example.